So, magsugon ako guys. Good morning to everyone. My topic is all about Biofloc technology, emerging microbial biotechnology for the improvement of aquaculture productivity. So, Biofloc technology is a system that maximizes aquaculture productivity by using microbial biotechnology to increase the efficacy and utilization of fish feeds where toxic materials such as nitrogen components are treated and converted to a useful product, like a protein for using as supplementary feeds to the fish and crustaceans. Thus, Biofloc is an excellent technology used to develop the aquaculture system under limited or zero water exchange with high fish stacking density, strong aeration, and biodata. So, in short, kaning BFT is kanang fish farming system bita or kanang pag-uma sa isda nga kanang nag-recycle sa mga kanang something nga hugaw sa sustansya isip as a food of the fish. Ang biofloc is kanang specific culture microorganisms are introduced into the water aron to form aron ma-form ang mga microbial protein gikan sa mga toxic waste sa isda o guban pang mga kanang something organic bitaw sa tubig. Then makatabang usab pud ni kanang to maintain sa quality sa tubig as well as lowering cost. According to Vizier and Nikasari 2017, biofloc technology applications are one of the best aquaculture system and contribute to the achievement of sustainable development and desired objectives for a clean environment, such as kanang mga feces and anethane feed in addition to some of the plankton and nematodes formed together to be integrated and interdependent ecosystem. So, Hargreaves 2013 defined the biofloc as a mixture of algae, bacteria, protozoa, and other particulate organic matter. So, moreover, biofloc systems can operate with zero or low water exchange or 0.5% to 1% per day. Then, under high stacking density of fish farming or shrimp, assuring it to be an ideal system for saving water exchange. So, biofloc is a mixture daw sa kanang mura bitag algae aning mga bacteria that can operate with zero lower water exchange. Moto, fish species that are suitable and not suitable for biofloc technology. So, fish species that are suitable for BFT are tilapia, common carp, shrimp such as pink, brine, and Pacific white leg shrimp. So, these are usually kanang suitable for biofloc systems that are sociologically adapted to digest microbial protein obtained from biofloc consumption. Then, fish species that are not suitable for BFT are kaning channel catfish, hybrid striped bass, prawns such as giant tiger prawn and giant freshwater prawn. So, they are not applicable sa BFT kay they cannot tolerate low water quality due to the high concentration of solids. And then, ang biofloc is generated by adding organic carbon and high aeration, which reduces toxic dissolved nitrogen in the water, where internal waste treatment processes are emphasized and encouraged. Although it is a potential technology, the data on operational parameters of BFT is still inadequate. Hence, there is an urgent need for more applied research on operational parameters of BFT to optimize the system, such as immunologically effects, microbial associated molecular patterns production, and nutrient recycling. So, kaning kuan is nag-design to highlight the application biofloc systems and urge to develop of this system to produce kanang more aquaculture production without any pollution to the environment and with limit natural resources of water and land. Development of biofloc technology as a novel microbial biotechnology. Microbial biotechnology which deals with applying microorganisms to ensure the security, safety, and usefulness of foods, yielding high-quality products, proper human nutrition, and defense against plants and animals diseases. it is still rising with different new technologies for sustainable development in the agricultural field. Nevertheless, uses of microbial biotechnology for sustainable development in aquaculture are critical because of the essential role of microorganisms in the establishment and control of ecosystem facilities, especially nutrient cycling, water quality control, and disease regulation in the culture system. BFT is one of such novel microbial biotechnologies that has been developed with an excellent eco-friendly technology not only for higher productivity but also for sustainable development. So kaning BFT maong gitawag og eco-friendly is because BFT is considered the new blow revolution since ang nutrients can be continuously recycled and reused in the culture medium benefited by the minimum of or zero water exchange. Also, the sustainable approach of such system is based on the production of fish or shrimp in a small areas. It is also environmental friendly aquaculture technique based on its microorganism production. In BFT, the microbes work for regulation of water quality through the control of nitrogen, resulting in the enhancement of the microbial proteins, which functions as a source of nutrition for aquaculture species. Moreover, the microbes in BFT play a vital role in biosecurity by inhibiting the pathogenic microorganisms growth. Then, ang example ani is heterotrophic bacteria such as Bacillus spp kanang nga magamit as probiotics for bio-augmentation of Biofloc enhancement immunity in the Indian white shrimp against the pathogenic microorganisms, resulting in better growth, survival, and productivity of the shrimp. Mao ni ang mga fish prawns species nga macultured mallet, Nile tilapia, kani mao ni sila shrimp, Nile tilapia mo na sila. So, Biofloc technology. So, kani ko na is biofloc composition and work mechanism. Successful fish farming is entirely dependent on the socio-chemical and biological qualities of water consequently. So, ang kaning water control is required for optimum ponds management. Some studies suggested that the ratio between nitrogen and carbon in the water during the period of aquaculture should be controlled by implementing successful biofloc technology. Mao ni ang BFT integrated system kani. Biofloc is the best system for water utilization and waste treatment. Fish and shrimp ponds contain a high load of nutrients because of the vast amount of feeds. Almost 50 to 70% of feeds is in the water or in the sediment, thus resulting in the water quality deterioration due to the imbalance of carbon and nitrogen in the culture pond. In such fish and shrimp ponds, biofloc technology can improve water quality by balancing carbon and nitrogen in the aquaculture system by photosynthesis and nitrification processes. So, kuan po na to nga, it was reported that the kanang optimum ratio of carbon and nitrogen in biofloc could help to maintain the water quality to raise the Pacific white leg shrimp in lower salinity for inland culture daw. So, in turn, it decreases the possibility of land pollution by the release of saline wastewater from the shrimp pond. So, in BFT, heterotrophic bacteria are the most common microbial community members forming the structure of biofloc. Simultaneously, the chemotrophic nitrifiers are fewer in number than other of bacteria, which in turn leads to less efflux and nitrogen to the ecosystem of the pond. Also, actinobacteria stimulate the formation of biofloc and could be necessary for secondary benefits of protecting against the fish pathogens. However, they may upsurge the accumulation of flavor in fish flesh and water. Some additives like glucose, starch, and glycerol are preferred as carbon sources to cultivate the biofloc culture. And these carbon sources are not only affecting the microbial community structure and composition but also affect the number of pathogenic bacteria, for example, katong Vibrio spp. The key factors of water quality check and BFT systems and its optimal under normal detective ranges. Temperature 20 pH, dissolved oxygen, tan, salinity, alkalinity. Biofloc is a safe integrated aquaculture system for higher productivity. The high-density fish and shrimp culture usually demand as a waste treatment infrastructure, and Biofloc is the best waste treatment system. It was revealed that the BFT system could be efficiently applied to upsurge fish production by establishing an encouraging relationship between Biofloc and fish density, which showed a higher capacity to recycle nitrogenous waste and high culture densities. Moreover, BFT systems are suitable for achieving aquaculture with an intensive aeration, low or no exchange of water, higher stocking densities and organic input, heavy mixing an additional advantage of the generation of an additional feed sources for some species well suited for this condition. So, however, kaning BFT was developed to secure fish rearing ponds from diseases caused by the pathogens available in incoming water. It was reported that chicory-based BFT enhanced the immunity of the tilapia against the pathogenic Aeromonas hydrophila infection through upregulation of various immune cells, immune-related genes and enzymes and antioxidant capacity. Thus, jaggery-based BFT was capable in growth of performances and the survival rate of the Nile tilapia. Likewise, the intensive cultivation of Nile tilapia can be established by using water discharge from Biofloc system during the growing period without negative effects on the fish survival and productive performance. So, moreover is ang part of the beneficial biota was kanang na-link with the particles of Biofloc, and the density of these particles could be regulated to some degree to increase production. A study revealed that the aquaculture performance of the shrimp japonicus in high-intensive zero-exchange farming system was improved by Biofloc technology, and this high performance might be related to the biodiversity of microbial flora. Furthermore, Biofloc particle size has played a vital role in some aquaculture species, nutritional quality and productivity. It was demonstrated that the combination of BFT with an integrated culture system resulted in lower suspended solid, higher biomass production, enhanced total feed efficiency, and higher nitrogen and phosphorus recovery. Advantages and strength of Biofloc technology. BFT has many benefits that distinguish it from many other advanced fish farming systems, such as an eco-friendly culture system with zero drain water after culture. Mo tong gingon ganina nga ang kaning BFT is zero drain water mo na siya, eco-friendly siya sa kuan nato. BFT is dominated over other system because of its higher capacity for reduction of environmental impact, kanang improvement of effective use of land and water, maintenance of the suitable quality of water with minimal water usage, and exchange within the rearing ponds and production of the protein-rich Biofloc as a supplementary feed for aquatic organisms. Arias Moscoso et al. Stated that Biofloc could ensure clean water and high biosecurity by reduction of wastewater pollution, as well as lowering the risk of introduction and spread of diseases and pathogens. Moreover, BFT enhances survival rate, growth performance, and feed conversion in fish culture system, urging its application as a more economical alternative to other culture system. Because of the generation of Biofloc as non-costly and adequate feed, BFT also reduces the need to utilize protein-rich feed, resulting in the cost-effective production of cultured animals. BFT also reduces the burden on capturing fisheries to market cheaper food, fish, and trash fish for the fish meal industry. So, mura bitag kanang gipaminos bitaw sa BFT ang kanang murag burden sa pagpanakop sa mga sa mga murag pangisdaan bitaw aran ibaligya og mas marato nga pagkaon nga isda o basura nga kanang ikuan sa fish meal industry. Disadvantages and weaknesses of Biofloc technology. There are many weaknesses in the Biofloc system, such as the urgent need for high aeration and water movement, which leads to the increased energy requirement for mixing and aeration. And then furthermore, several disadvantages are also reported for BFT, such as reduced response time because of consumption of dissolved oxygen in the water and high respiration rates, potential pollution from nitrate accumulation, and the requirement of start-up period and alkalinity supplementation. Moreover, the performance of BFT may be inconsistent and dependent on seasonal variation of the daylight period for sunlight exposed system. Ang BFT has some frequent requirements of maintenance which sometimes may be too mahal, expensive. So, conclusion. Biofloc technology is an innovative and effective microbial biotechnology in which toxic materials such as nitrogen components can be treated and converted to a useful product like proteins, which can be used by the fish and crustaceans as supplementary feeds. It is an excellent technique to develop the aquaculture system under limited or zero water exchange with high fish stocking density, vigorous aeration, and the biota formed by Biofloc. BFT presented aquaculture as a sustainable tool for the environmental, social, and economical issues that are synchronized with its growth. So this technique needs to be developed by more researchers to keep up and maintain the aquaculture system in the future. That's all.